2.4 linear inequalities. We will see graphing inequalities and interval notation, and then in the next subsection, solving linear inequalities. First, let's see how to graph the inequalities and the interval notation. First, we will see the symbols used in inequalities. This one is less than, greater than, less than or equal to, greater than or equal to. And okay, that's when we say inequality, we will have, for example, we have some algebraic expression here, less than or equal to some number, or it might be some other algebraic expression. So this is just an example here. So when we say inequality, you will understand this type of thing, but it's not limited to the variables. Okay, some related concepts. If you have in an inequality, if you have this one or this one, so it's a strict inequality. We will say x is definitely bigger than 2, or x squared plus 2 is bigger than 2x. Now, and double inequality, it is this type. There's a lower bound and there's an upper bound for it, and it might be strict or not. And the other thing is the interval. So this is an important thing. You will hear this interval issue. This interval is this one, all the set of the x's between b and a. We will tell them by this notation. The set of all x values bigger than a and less than or equal to b, it will be represented by this notation here. And you see, if there's a equal to case, we put this bracket equal to, if there's equal to case here. So this is, so if you use this one, no, not equal. So it's a strict inequality. So if they're both equal to, so we say this is a closed interval. So it's basically x is bigger than or equal to a and x is less than or equal to b. Okay. Now open interval, okay, so here is the, okay, this is closed and this is strict inequality here. So you see, I'll look at here. Now, here is different types of intervals and inequalities. These are the basic inequalities and intervals. For example, look at here. This we say both sides open, a not included and a b not included. Sometimes in some books they do it this way. So they put open circles here, like a, b. Or here we will use this one. Now a included but not b included, a not included, b not be included, and a, b both included in the set, like in the interval. Are all included here. And if we are talking about this part and there is no end for it, we say negative infinity. So it starts from negative infinity, goes up to a, and a is not included. And if there is no, again, limit on this side, it goes to negative infinity, and here ila nihaya, okay? This one is closed, so we write a. And if this goes this way and there's no end, so it's plus infinity. It's positive infinity here. And if we have no limit on the right side and the left side, we use negative infinity to infinity. So this is the biggest interval we have, and it is telling us the whole real line, and the set can be given as this interval or we say the set of all real numbers. Let's look at this example. Express the following as an inequality, an interval, and a graph. X is greater than -2. It is obvious as an inequality. It's x bigger than -2, -2. And as an interval, it starts from -2. We can say it's -0 is here and -2. -2 is not included. And it starts from here, and there is no limit for this part. So there's no upper limit here. So it starts from -2, -2, and it goes endless. So it goes endless, we put the infinity here. So it has to be, the interval has to be -2 to infinity. And one important thing about the infinity, we always use the parentheses, the curly parentheses. It's used this one all the time with infinity, or here. We never use the brackets here. Don't use the brackets with the infinity. And the graph will look like this one. And let's look at part B. And part B, x is less than or equal to. And you know what it means. It means less than or equal to. And there is no lower bound here. And there is the upper bound 7. So it means it goes up to 7. So it will go up to 7. Here, 7. And less than 7. And there is no limit here. So it goes endless. So then it has to be minus infinity, or negative infinity to 7. And this is with the bracket here, because this is equal to, there's the equal to condition. And the graph will look like this one. And x is greater than or equal to -1 and less than 3. So it has a lower bound and an upper bound here, the lower bound and the upper bound, less than 3 and greater than or equal to -1. And so it will be here the bracket with the bracket. And this one will be with the curly parentheses. And of course the graph will look like -1 with the bracket, and then 3 with curly parentheses. Now let's remember what is union and what is intersection. So this is a reminder. The union means when we say the union of two sets, we take all the elements in A and all the elements in B, and we put them together, and it makes the union. Then intersection is the elements that are common in B and A. So there's the AND condition here, and there's the OR. So OR condition used like whatever you take, whatever you see in the A and B, take them. But here AND means you have to take the common elements in A and B. So the intersection of intervals and the union of intervals. So for example, look at this two intervals. Okay, I will show the graphs of them. And let's say this is 2, this is 3, and here this is 2.5 to, like, let's say 10. Now when you look at the intersection of these two, you look at the common parts. So the mushtarak common parts. Then the overlap, the intersection will be this part. So we will say this from 2.5 to 3 is the intersection. But when we say the union, when we take the union, we take this and this, and together it will make 2 to 10. So this is A union B. Okay, we will come to that in coming exercises. Okay, let's remember the definition of whatever you put in both, you put them together, it makes the union. Whatever you put you want to find, okay, in the intersection, you're just choosing the common elements here, 3 and 2 and 2 and 3 here, and this is the intersection. Now let's look at this example. It gives the closed interval, and it gives an open interval. It gives another interval here, and we want to determine what their union and the intersections, and we want to write them in interval notation and graph them. Okay, here are the sets, the intervals, A, B, C, and okay, we want to find their intersections and the unions. Okay, here are the interval notation of them and the graphs of them. Okay, now let's find the union of A and B. A union B, this is A and this is B. Okay, this is A and this is B. When taking the union, you're taking all the elements of A, all elements from A. When you're taking all the elements of B, and when taking the elements, we are taking the common elements also, as you see, the mushtarak elements, and the ones not mushtarak. So this becomes -2 to 6. Okay, you take them from both. And this I'll be right. This one is an interval notation. This A intersection B. In A intersection B, we want to find the points that are in A and B. So they're mushtarak, they are common. So this, okay, these points, you see that it's not mushtarak. But when we look at these points, they are both in A and B. So the intersection will be this part here. So it will start from 1, but 1 is not included, and it will go up to 3. So this part here is the intersection. So as you see here, this part will be the intersection 1, 3. And then, of course, it will be, the interval will be from 1 open, 3 closed. B union C, okay, let's do B union C. B union C, so start from 1, take all of them. B, I'm taking all the elements from B, and from also C, and this is, it looks common because they have the same elements here, and I will go up to B, so it seems we have 1 to 6. And we can write it as 1, 6. Now let's come to B intersection C. B intersection C means we're tracking the common elements, so that are both in A, in B and C. So look at these elements. These elements are common. So it will be from 4 to 5. Indeed, C is a subset of B. C is a subset of B, indeed. So the intersection will be again C, or 4 or 5. And A intersection C. Okay, let's check A intersection C. A intersection C. Okay, where is C? Okay, now let's try to find the common elements here. The common elements here, and when you look at here, there is no intersection between them. Look here, when you go up to here, So the 3, when you take the projection onto this real line, 3 comes here, and there is nothing common between them. There is no overlapping. So we say there is no intersection. It's empty set. Then when we say the A union B, okay, you are taking all the elements of A up to 3, and then A union C. Then there's a jump here. When there's a gap, nothing is here, and then it starts from 4. So the graph will look like this part and this part. So there's a gap here. There's a gap. So there's a gap. In this case, if there's a gap, we cannot include this. This is not included. It's not included in the set. So in this case, we just use union. So this union is not, it doesn't include this part here. So for if it was included, I would say -2 to 5. But this is not the reason. This is not true, because this part is not included. So we cannot combine them and write them as one. So I will say we cannot write it as one interval, because there's a gap here. Now let's see how to solve the linear inequalities. Okay, first let's see what is a linear inequality. A linear inequality is it involves the degree, the first power of x, and there's the inequality symbol. So this is called linear inequality. And so what is the solution of a linear inequality? X equal to 0 is a solution of this inequality, because when you put here 0 and 0 here, then it gives you a true inequality. So if it gives you a true inequality, then it's a solution. So the value, the x value making this inequality true is a solution of the inequality. So for example, it's -10 is not a solution of this, because when you put -10 here and -10 here, you get -5 bigger than -20. So this is not true. So this is false. So we say this is not a solution of the inequality. So how many solutions are there for an inequality? An inequality generally has infinitely many solutions. Okay. So for example, how many x's are there satisfying this? Many, infinitely many. 3, 4, 5, 6, 7, 1,000, 100, you know. Infinitely many. The solution set for an inequality is the set of all solutions. And the two inequalities are equivalent if they have the same solution set. Okay, how to solve a linear inequality? The main method is, the first thing is you have to isolate x. This is the main thing. But we have to be careful about this issue here. When isolating it, if you have to multiply or divide both sides with a negative number, you have to change the direction of the inequality. So if you have such thing, if you have like x bigger than 2 or something, you want to divide with -1, you have to change this one to here. Okay, it's x bigger than 2. If you're doing this way, like dividing by -1, you have to change this. And it's true if It's true when it is multiplied with negative. So for example, you want to multiply with negative both sides, and you change the interval. Change the direction of the inequality sign. This is important. Now let's keep them in mind and let's solve this problem. Solve and graph the inequality for minus 3x less than 22, and express the solution in set builder and interval notation and graph it. Okay, first let's write the inequality here. Okay, you can subtract 4 from both sides, and you can get negative 3 less than 18. And you want to isolate x. How can you do it? If it was this, what would you do? You divide both sides with negative 3, right? So you will do the same thing. But be careful here. Dividing with minus 3 changes the direction, you see? Important. This is very important. Don't forget this. And then we get x bigger than minus 2. X bigger than minus 2 means all the x values bigger than minus 6. The set of all x's such that x is bigger than negative 6. This is the set builder notation. Interval notation, x is bigger than 6, but there's no limit for this side, so we say infinity. And in the graph, we say negative 6 to infinity. So you can take this one as infinity. So it goes endless, and we put the infinity here. Now, let's solve a linear inequality using LCD. Here we have an inequality. It's a rational inequality. So we will express the solution set in set builder notation and interval notation. Okay, first you can get rid of the numerator and get rid of the denominators. Makam here. The best thing to do is like using LCD. 2, 3, their LCD is 6, so multiply both sides with 6. You don't have to change the direction of the inequality sign because this is positive numbers. These are positive 6, positive 6. And then there will be cancellation here. 2 times 5 times x, and this is 6, 3, it makes 3. 3 times 4 plus x, and then try to isolate x. So isolate x means like send x to the other side, or subtract 3x from both sides, and you get 3x goes here as negative x, and there's the 0 here, and we have 7x is less than 12, and divide by 7 both sides. No change in this direction here because this is positive. And when you write this one in as a set builder notation, you can write it this way. And the interval notation, so there's a upper bound here, but there is no lower bound. So you put negative infinity. And because of this equal sign here, we have to put the bracket here. Solving a double linear inequality. Solve the inequality negative 2 less than or equal to 3x plus 1 less than 13. So it says express the solution set in set builder and interval notation. Okay, our goal is this. So we have this one. Okay, we will do some operations and get this one. Okay, how can we do that? First, you can subtract 1 from all sides. 1, 1, 1 subtract, so that we get rid of 1 here. And we have 3x here in the middle, and negative 3 on the left side, and on the right hand side this is 12. And then next you have to isolate x. How? By dividing by 3. Divide. Then since it's positive here. This is positive. No change here. No change in the direction. No change. Okay. Then there will be the cancellation, and we end up with this. X is bigger than or equal to -1 and less than or equal to 4. So this is, in Saar-Biel notation, you can write this way. The set of the x values such that x is bigger than or equal to -1 and less than 4. And in interval notation, it's -4 in bracket and -1 in bracket. You see the equality sign, and this one here open. Okay, we will see two more things. Some linear inequalities are connected with and or. For example, find the set of all x values that satisfy this and this. So this and is giving you an extra condition here. It has to satisfy this and this. So what is this x values here? What are these x values? So we want to find, so and is making an extra condition here. So it says it has to satisfy both inequalities at the same time. And look at here, it says find the set of x values satisfy this or this. Okay, this is a weak statement here. So that only this enough or only this enough. But here it says and is saying it has to be both satisfied. So how to find them? Let's start with part A. Now this is wanted, so we can write it in Saar-Biel notation. This and this is wanted. So the x value is such that 2x minus 4 less than x and x minus 4 less than 2x wanted. And then we solve each of them. So how? Isolate x. So extend x to this side and -4 to this side. We get x less than 4. And send this one here, or no, x here, send x to this side. You get bigger than -4 and x bigger than -4 here. So we end up with x bigger than -4. And the next thing you have to do is and. Okay, we put this condition here, and. So and means here we'll take. Okay, then the next thing is to write this one as an interval and write this one as an interval. And is, if you remember, it was the intersection condition and. So then we put, remember this, if x is in A and x is in B means and, means A intersection B. So we take the intersection and then the intersection of these two intervals. Okay, I can do it this way. -4 goes up to 4, and then this one goes -4 up to infinity. So the common part is this one, so it has to be starting from -4 up to 4. I'm taking this part. It's the common part. So it's -4 to 4. So this is the solution. So look at, okay, then. So here, this means like whenever you take any point from here, it satisfies both. Like for example, take 0. 0 is here. X equal to 0. So put here 2 times 0, -4 less than 0. So this means -4 is bigger than 0. Yeah, this is true. And at the same time, when you put here 0 minus 4 bigger than 2 times 0, is it true? Yes. These two equations, these two inequalities are satisfied by 0. So this is a correct set. Negative 4 to 4 is a correct set for the solution of this problem. And now let's come to the second. So we have OR here. We will do exactly the same thing, like solve them and solve them. And let's remember this. Remember, the A union B was, okay, the set of X is such that X is in A, or X is in A, or X is in B. So if you have this statement here, or, it counts for the union. So union. So if it is union, how can you find the union? Negative 4 to 4. And negative 4 here, let's start from here. So then it goes up to infinity. Here it goes to infinity. And now we take all of them, like this one, all the elements starting from here, and then it goes up to here. Then I'm taking the elements from here only because nothing left here. So it will be negative infinity to infinity. So I'm taking the elements from each. No need to look at the mushtarak. No need to look at the common ones. I take all of them. So we have negative infinity to infinity. Okay, as a summary, these are the important highlights. Okay, one, inequality notation, you have to know it, and you have to know the set builder notation and the interval notation. This is the very important one. You will use it a lot. And the graphs, you have to know it when doing the intersection and union. You will see, you will visualize it and then do the intersection or the union of the graphs, the union of the intervals by using the graphs, by visualizing them. And the last thing is when solving the linear inequalities, you're trying to isolate the x, but this is very important. When you multiply or divide by a negative number, you must reverse the inequality sign. So if it is like that, you make with minus here, so you change. Okay. Thanks for watching.